I recently got this 315 MHz transmitter and receiver pair which works in the free for public use frequency band and is a little less in cost than the 433 MHz transmitter and receiver pair. Yes, they are different. This will be a multi-video series about RF wireless control. So in this first video, we will see the working of this 315 MHz transmitter and receiver pair, how to connect it in order to use it and its different applications. The first thing we can do is to take a proper look at the boards itself. Now, although the inscription on the shiny transistor is 433, there are other differences that allows us to know that this isn't a 433 MHz pair but a 315 MHz pair. There is supposed to be a coil at this place which is empty at the transmitter side, and there is an inductor missing at this place in the receiver. I didn't find any specific documentation about this though. But when I tested the transmitter with an actual 433 MHz receiver, it didn't work. Same with the receiver with an actual transmitter. So I assume these components may only be the difference. I may be wrong though, so when you buy these, do ensure with the seller that you get the right one. Okay, so with all that out of the way, let's take a look at the pinouts. The transmitter has 3 pins, GND for ground, VCC for power and ATAD for data. They wrote data in reverse. And at the receiver there are 4 pins, VCC for power, then the 2 middle pins are both for data and the 4th pin ground for ground. Now we can proceed by placing these boards onto a breadboard and start testing them. But as these are advertised for quite long ranges, we should first see how we can make an antenna for them. We will need some enamel coated copper wire. Now according to the results I found online, the best suitable antenna would be the length of a quarter of the wavelength of the operating signal. So the frequency is 315 MHz and the wavelength is approx 95 centimeters. So divide that by 4 and we get approximately an inch or 24 centimeters of length. So we cut the wire at that length and then use a rod or a screwdriver to coil it into an antenna. And after that we can solder it to the antenna pin like this. Now finally we can proceed to the testing of these boards. I placed a switch on the breadboard on the transmitter side and made the connections. Now I only used one breadboard to demonstrate a wireless TX and RX pair. Yes, because I am powering them with the same source. The data pins are not connected in any way other than the wireless connection itself. So at the transmitter side I connected the ground pin to the ground rail of the breadboard, VCC pin to the VCC rail on the breadboard, and I connected the ATAD or data pin to ground through the switch. And also I connected a 10 kilo ohm resistor to pull up the data pin. At the receiver side I connected the ground pin to the ground rail, the VCC pin to VCC rail, and the data pins to an LED through a resistor to ground. The operating voltage of this board is 5 volts, so I set the voltage on the power supply at 5 volts. Now when I turned on the power supply, we can see if I press the switch, the LED on the receiver blinks when I release the switch. We can also adjust the screw down here to tune the receiver, and after that we can observe that it works. I was noticing some current spikes, so to smooth them out I attached an 10 microfarad capacitor. The next thing I did was to connect my 555 based frequency generator which I built years ago. I connected the square wave output to the data pin of the receiver, and as you can see, whenever the signal is applied, the LED on the receiver blinks. Although I wasn't sure if these transmitter and receiver pair was working properly or not, so I removed the antenna and attached a 100 microhenry inductor to the receiver where there was an empty footprint, and then tested it, and it worked. So I think I was right about those components being the difference between them. Now we have a working wireless system for one switch and one application. But there are problems here. One is that if there is another TXRX system in range of our system, it will interfere. So in the next part of this series, we will take a look at how we can eliminate that problem by giving our wireless system an address, and also to extend the application of the system. So make sure you're subscribed to my channel and you have pressed the notification bell so you won't miss the upcoming videos. Also, if you liked this video, please do like, comment and share this video. Thanks for watching.